Thank you very much. We're up all good. Okay. I'm thrilled. I was thrilled to be invited, and this is certainly one of the most beautiful places that I've ever been to a programming conference at. And I'm also not going to be able to impress you with my Russian like Yale, because the only word I think I know is yeah. Possibly also vodka. Okay. So I'm going to tell you a little bit about Python packaging and how it's hopefully better than it was before. But first, let me tell you a little bit about myself. So I've been contributing to CPython, doing Python implementation for almost 8 years now. And it doesn't feel like it's been that long, but I feel old now. And I've worked on all parts of CPython, especially I'm interested in compilers. So I've also worked on PyPy, just-in-time compilation, and sort of applying people's patches, which have been sitting on our tracker for a very long time. I also wrote the 6 compatibility library, which I was happy to see appear us on the program for the conference. You can see somebody is importing 6, so that was exciting. And what else? Yes, I've also worked on PyTest a bit. Specifically the sort of magical debugging features which PyTest has for assert statements. I worked on that, and it's scary. Okay, and I've just been generally around in the Python community for a while. Okay, so I'm supposed to be talking about Python packaging, but Python 3.5 was released less than a week ago. So I couldn't resist the temptation to spend a few minutes talking about some of the things which are new in Python 3.5. So the first thing is now you can use formatting with bytes. So you probably wouldn't actually say this with byte strings, you'd use a Unicode string, but that's so. This is just like percent formatting for traditional percent formatting. Waivers. Okay, I can't point. I guess that's what happens when you have a red slide background. I didn't think of that. Okay. But we do have cursors. Okay. So it works just like string formatting in Python 2 with a percent symbol, where you put stuff in a tuple or a dictionary, and then it gets substituted back into the format string. And so you see you're using the B code here, which is sort of like %s in Python 2 or 3 string formatting. And you see it's still intolerant of mixing bytes and Unicode strings here. So if you try to insert a Unicode string into a byte formatting string, you'll get an error. So this will be very helpful to people who write networking protocols in Python, because you often need to format binary strings like this. And so that's part of the reason why this doesn't use the format method, which was a new formatting syntax added also in Python 2 and 2.7. But most sort of older protocol code is using the percent formatting because that's been in Python forever. Another fancy syntactic feature is generalized unpacking. So Python 3 has had this little unpacking syntax for almost all of its lifetime, where if you have an iterator on the right, then you can put a star to sort of to collect the rest of the iterator, which is left over from the signal unpacking here. So that's what that gives you. But now in Python 3.5, you can sort of flatten sub-iterators into a literal. So here, this is a list literal, and then the star here, this is just the list 3, 4, causes that literal to be flattened into the range to be flattened into the larger iterator, so you end up with a list of numbers 1 through 5. And the same thing works with dictionaries. So this causes except with double stars. So this causes the inner dictionary literal here to be flattened in the other one. Of course, this example is kind of contrived because you should just write B and C in the outer dictionary literal, but it was cool if you have a variable. And this also works with function call syntax, so you can have multiple stars and multiple double star arguments in function call syntax. Another big thing which happened is the introduction of coroutine syntax. So Python has had something resembling coroutines with generators since 2.5, Python 2.5, where you use yield and the send method and throw method of generators to kind of implement coroutines. But now there's a special dedicated syntax for asynchronous operations. So you can see the syntax is so new that the syntax highlighter doesn't know that async and await are keywords now. And so this is way too complicated to get into detail, too much detail, but basically this syntax, async def, creates a coroutine, and then await works sort of like yield, but it's more general. And so you could imagine that this fetches a document from a network or something asynchronously. And there's also a asynchronous for and asynchronous context manager syntax, which lets you iterate. It's syntactic sugar for making an asynchronous call on each iteration of the for loop. So there's a lot more to say about that, but don't have the time. And then there's just a few other things. So now there's a matrix multiplication operator. It's the @ symbol. It's not actually implemented by anything in the standard library or any standard types, but it's called a matrix multiplication operator because NumPy is going to use it as such. But I sort of expect that since it's like all other Python operators, you can overload it. I expect somebody will be using it for an email class or a Twitter client or something. And also PYO files are gone. Maybe you didn't know what a PYO file is, and that's fine because you don't need to know. And there's also something called scander, which lets you lazily iterate through the contents of the directory. So if you call os.lister today, it'll read all the contents of the directory into memory and put it in a list. But most of the time, if you are listing through a dictionary, you only need to, or a directory, you only need to look at every item, each item once. You don't actually need the entire contents of the directory in memory. And so this provides a way to do that. And then another large thing was a syntax for type hints. And now there's a typing module, but there's no type checker that has to be provided externally. And that's a whole other big topic. Okay, so now that I've indulged in that, we can go back to packaging, which I'm actually supposed to be talking about. Okay, so why is Python packaging so important? Why do people talk about it? Why do people write angry blog posts about it? Why do people say that Python's packaging is bad? Why do people say that we should try to implement some other sort of packaging scheme? We should use apt packages. I think what it fundamentally boils down to is that Python has great libraries, and people want to use great libraries. Gail wants to use NumPy and other people want to use scikit-learn, and because they implement these useful things which are certainly not in the standard library or in the Python core language, and other people want to develop web apps, which now requires having a huge stack of dependencies, Django, it's like a 7 megabyte download. And so one of the most useful features of Python language now is that it has a large ecosystem with a lot of great libraries. And since packaging is the act of letting other people use libraries, that it becomes so central to the language. And I think what this means is that packaging, or the ability to use Python libraries well, is as important as Python syntax. It's a little strange because when you're first designing a language, you think about, oh, what is the syntax going to be? What are the object models going to be? How will I accomplish basic programming tasks? How will subroutines be defined? How will I load modules and these sorts of questions? But I don't think a lot of language designers think about how packaging is going to work in their language, and that's partially because you don't start worrying about it until people have written so many great libraries in your language that packaging becomes a core workflow many people use in your language. So the usability of packaging becomes just as important as the syntax features which you carefully crafted when you were first creating the language. And so another reason why packaging is such a large and difficult topic is that there's so many different people who need to use packaging and have it work for them. And I think it's safe to say that everybody who does Python these days has to interact with packaging somehow. So there's everybody from library authors to people who are deploying the same code across thousands of servers somewhere. But there's other people who are writing apps which they want to run on Windows or command line tools like Mercurial. And these have very different needs from server apps. And then there's also people who want to learn Python. And a lot of people learn Python in order to use one of the great libraries, and so they need to install NumPy or something so they can learn Python and do their scientific work. And that's very different from deploying apps on the server side. And that's just one of many. Everybody has to touch Python packaging. But when you think of Python packaging, what do you think of? Do you think of like there's one standard solution which works for everybody and we love it and it's great? So I don't think that's really true, and I just sat down and wrote the first 15 or something words which came into my head when I thought about Python packaging, and it's it's very scary and confusing if you're not sort of like steeped in the stuff and the soup of Python packaging. I know Python pretty well, I think it's safe to say, and when I was writing this talk, I had to disentangle a lot of the things here. So Python packaging is huge, and it doesn't refer to exactly one thing, and it refers to a lot of confusing, possibly deprecated things. But I think one word which many people think of when they think of Python packaging is pain. I tried to make it especially painful since I wrote pain in this awful font. So it's and this drives a lot of people away. People want to just be able to sit down and have things work out of the box, like scikit-learn, right? Most people do not care about what version of GCC they have and whether that's one which works with NumPy. They just want to sit down and analyze their data or something. And they don't want to have to debug pip or setup.py. What is even setup.py? They don't know. So it's understandable that people have a very adverse reaction every time Python packaging is mentioned. And hopefully I can convince you in this talk that things are not quite as bad as they were. They'll never be perfect. Okay. So what I mainly wanted to do during this talk is survey some of the core technologies which are emerging as the forefront of Python packaging. And each one of these things could have several talks devoted to them, and Python packaging could have 50 talks devoted to it. So I'm just going to talk very, very generally about where these projects came from, what they're doing, and how they fit into the Python packaging ecosystem. So specifically, I'm going to talk about Disutils, which is sort of the original Python packaging solution, pip and virtual end, which are newer, and wheels, which are a new format for distributing Python packages, and finally, the Python package index, or PyPI, or the Chi shop, which is the online catalog and repository of Python packages. Okay, so let's start where it all started, Disutils. So, back in the 90s, if you had a Python package which you wanted to distribute, you hoped that it was just pure Python because then you would just put it in a tarball or a zip file and then upload it to your personal web server or source storage. And then people could download it and copy it somewhere onto their sys.path. And if you had an extension module, though, then you would have to provide a makefile which passed the right compiler flags to the compiler in order to have it link properly with Python. And probably you'd have to write some custom code so that people could install the compiled module in the correct place. So as you can imagine, that was pretty frustrating for everybody. So in one of the early Python conferences in 1998, a bunch of people got together and said, we should figure out how to do this better. And thus Disutils was born. And there were several people who were involved in this, but one of them was naive enough to get roped into writing most of the code. His name was Greg Ward. And he worked pretty hard on it. He wrote basically all the Disutils code that we know today. And he worked on it for 2 years, and then he got burned out. This is a common story in Python packaging, unfortunately. And so active development of Disutils stopped. It worked pretty well for very simple compiled modules, and so that was a very good start. And now Disutils has been dead for 15 years. And so after a few years, people realized that Disutils was not meeting all of their needs, and since Disutils was dead in the standard library, and it was kind of hard to change, they started writing their own custom libraries on top of Disutils to help with Python packaging. So probably the most famous one is Setup which was started in 2004, and has both features for package authors, like entry points, and for library users, like the easy install installer. And so this went on for a while, and then in 2008 there was a set of project called Disutils and Packaging, and they said, okay, we're going to sit down and we're going to rewrite Disutils and we're going to fix it, and it'll work, and then we'll put it in the standard library and it'll be great. After 2 years, Tarek got burned out and that never worked. unfortunately. Okay, so the central object in Disutils, as you probably know, is called setup.py, and it's both a repository of library metadata, like what source files to install, what C extensions to compile, the name of the author, and so on. And it's a command line tool for doing things related to packaging. So both for the library author, there's commands like building source files or tarballs and uploading them to PyPI, but also for the way you install a traditional Disutils packages, you run setup.py install. And so the fact that setup.py is executable is a very old fundamental decision of Disutils. And it allows a lot of flexibility because it means you can have arbitrary code running during packaging, but it also creates unreliability because you can have arbitrary code running in setup.py. And it also makes package metadata hard to extract without running code because you don't know what the actual library metadata is until somebody runs the setup call. So if you've ever looked in a setup.py file, you've probably seen something like this. It imports the setup function, which is really the only API of Disutils. And then there's probably like 200 lines of really obscure, gross, monkey patching of Disutils, and maybe they import setup tools, and then if it's not there, they try to download it, and all sorts of really unpleasant things. And then they like monkey patches, so there's extra compiler flags on some files. And then finally get to the bottom, the punchline, setup.py, and the setup function, and then they actually call setup, and setup has probably like 50 arguments, and you're amazed that it works. Okay. So, as I was saying, since active development on Disutils basically stopped in 2000, it's been mostly frozen, and every once in a while, some brave person will try to fix a bug and be rewarded with 5 more bug reports about how they've broken compatibility with something because they fixed the bug. And people mostly took to writing new things which supplement and sit over Disutils, like setup tools, pip, and distlib, among others. Okay. So now all packaging has kind of been devolved, taken away from CPython development, and is now under the umbrella of something called PyPA, or the Python Packaging Authority. And even though many of these tools, such as setup tools, pip, and virtualenv, and PyPI, are all written by different people, now they've all been brought under the Python Packaging Authority. And the Python Packaging Authority is responsible for maintaining these libraries, as well as creating the standards for which govern Python packaging. And these are in the forms of PEPs. And so Python enhancement proposals, which are more traditionally associated with actually enhancing the core Python language. But there's probably about twice as many PEPs about packaging than there are about any other subject because it's so complicated. And they also have the responsibility of actually accepting and saying that these PEPs are going to be standard, because Guido has totally washed his hands of packaging and he hates it. Okay, so next thing we're going to discuss is pip and virtualenv. So pip is short for pip installs Python, or pip installs packages, or some other recursive acronym if you want. And it was created in 2008 by a man named Ian Bicking, who also created virtualenv. And he wanted something which was better than easy install, which is the installer, which comes with setup tools. And so it was kind of a little project of his for a while, but now pip is actually the official Python installer, and the main way that that is represented is that it's recommended by the documentation, and it's included with CPython distribution in Python 2.7.7, I think, and also Python 3.4. And so that means that everybody who has one of the more modern versions of Python also has pip, which means that they can easily install Python libraries, unless they're on Debian, in which case this has been broken. Okay. And so since pip is under the umbrella of the Python packaging authority, it is the package manager which sort of is the canonical implementation of many of the new packaging standards. Okay, so virtualenv, as I said, was also created by Ian Bicking in 2007 because it's very useful because it provides a way to isolate Python packages away from system packages and other Python projects which you might be working on in your system. So a lot of times you don't want to install Python packages into your system site packages directory where it can be accessible by all Python code because you might have incompatible versions and it's hard. You really want isolation with all those dependencies. And so there were a lot of hacks to do this, and virtualenv kind of just codified the horrifying hacks. But since it was so popular, it was sort of decided that you couldn't break virtualenv because it was so important, even though it was very ugly. But now, in Python 3.4 and greater, there's a built-in version of virtualenv called pyvenv, and since it's built into Python, the interpreter was able to be modified so that it supported virtualenv much more naturally, and it didn't need the sort of traditional virtualenv hacks. And so the result of pip in this is that if you just have Python 3, that's all you've installed, you can do something like this, where you use the VM module here to create a virtual environment. So that creates a virtual environment and it installs pip into the virtual environment. So now we can use pip to install Django, which will go to PyPI and download Django and install it and all its dependencies. And then we're ready to create a Django project. So this doesn't seem that impressive, but the fact that you can do this in 3 lines with a plain install of Python is quite a lot of progress, because originally everybody's tutorial, like using Django, you would have to like install all this, run setup.py and open tarballs, and there were a lot of ways to fail, but this is very simple and sweet, and you get an isolated version of Python in which to start writing your app. So this is a pretty excellent achievement in my opinion. This should be very easy. Okay, that brings us to wheels. So this is wheels as in car wheels or wheels of cheese. So what is a wheel? A wheel is a new format for distributing Python packages, and its containing format is a zip archive, and the zip archive has a lot of special files in it which are actually part of the wheel format. And so a wheel, so you can distribute both compiled versions of Python extensions, so things which need C code, and you can install pure Python packages with wheels. The main thing about wheels, though, is that to install a wheel, you do not have to run setup.py. So you basically just copy a bunch of things from the wheel archive into wherever you're installing it. And so that removes the possibility of setup.py containing bad code, which causes errors and makes installing packages a lot more reliable and faster. And then the actual file names of wheels have a special convention which tell you what kind of environment you can use them in. And so rather than actually digging in and talking about that, I'll just show you some examples. So this is the cryptography Python package, and they have a lot of wheel files, so everything except the bottom thing is a wheel file. And so they have C extensions, so C extensions are generally only compatible with one major version of Python and one operating system. So you can see that this is, like, the top one here is a cryptography 1.0.1 for CPython 2.6. And then the none is another sort of more specific environment classifier, which and then it's for Mac OS and what version of Mac OS. And then so for down here, you can see there's binaries for most of the modern Python versions and operating systems. So that's what you can do with Python wheels. Another cool thing about Python wheels is that they can be cached by pip, so locally, so you don't have to download them repeatedly. So if I just install Django on my pretty fast network from scratch, it takes 15 seconds to download Django and install it. But then if I remove Django and then I install Django again, pip will use the cached wheel of Django, which it downloaded before, and that makes the installation 7 times faster. Okay, and now we have gotten to the last topic, which is PyPI, or the Python Package Index, also known as the cheat shell. So PyPI, around the same time that people decided that we needed a better way than Makefiles to distribute Python extensions, people decided that there should also be a catalog. And so there was a working group formed called Catalog SIG. Once again, one person got roped into doing most of the work somehow. His name is Richard Jones, and so he actually wrote most of PyPI in 2002, and he wrote a paper describing how it worked and how packaging tools could interact with it to find out information about Python packages and download things. So the original implementation was very simple, and then people wanted it to do more complicated things. You know this story very well, I'm sure. And so the code base has added a lot more lines of code and not a lot more abstractions or sort of design principles. And so at this point, the code base is quite scary, and that's not so good for a service which needs to be very reliable, because everybody's tests and deployments depend on being able to talk to PyPI. And so part of that has been fixed by moving the PyPI infrastructure around. So originally, PyPI, for most of its existence until about 2012, was hosted on this shared host with every other part of python.org, so python.org, bugs.python.org, Python repositories, or Kernel repositories, and that started to cause problems when PyPI became much more widely used. So now it's running on cloud, and there's actual ops people handling the infrastructure rather than unwilling volunteer sysadmins. So PyPI today is quite a more serious service than it was in 2002. As I said, the reliability has been improved a lot. There's a caching CDN in front of it now, which makes downloading a lot faster in many parts of the world. And everything is done over HTTPS using the best sort of web security technologies. And so for a lot of Disutils history, it would always talk to PyPI over HTTP, which is kind of alarming if you imagine someone sniffing your password and you are like the author of the most popular package, Python package, like requests or something. You can imagine that would be a vulnerability for many companies. But now everything's done over HTTPS. And as I said, there's a CDN, which makes things much faster. And so PyPI has been growing a huge amount just in terms of number of requests and bandwidth. So this spring there were about 35 million downloads a week compared to 12 million a year ago. And so that now amounts to about 5 terabytes of bandwidth a day. And we get about 1 billion requests a month. Well, actually more than that now, 2 billion, I think. And it's partially because PyPI is so much more reliable and supported now. It's now the very strongly recommended place to put all of your Python packages. Originally, PyPI had this rather complicated mirroring infrastructure which allowed people to host their packages off of PyPI, and PyPI would just refer to them. Now we're really asking people to put their packages on PyPI because we think it offers the best performance and stability for users. Okay, but as I said, the PyPI codebase is kind of showing its age. So there's a totally new version, a rewrite of PyPI being developed called Warehouse. And Warehouse is cool because it has nice code. And there's actually a paid designer to work on the interface, which is pretty cool for an open source project. It's written in Python 3. And somebody's getting paid to work full time on it. So I think I can actually, can I open a new tab? Oh dear. So it's warehouse.python.org. Okay, maybe we can afford this. Oh, excellent. Okay, I've been saved. Live demos. Oh, I forgot the T. Okay, excellent. All right. So this is what Warehouse looks like. It's still very much in development. For example, if you try to search something, it will tell you that search is not implemented yet. But this is a feature. So it has a nice minimal design. So that is what the future looks like, hopefully. Okay, cool. Oops. Okay, let's hopefully not be in the tab context. Okay, excellent. Yay. Okay, so the last thing I wanted to talk about was just trying to boil down some of the core principles which are being used in the development of Python packaging now. These aren't written down anywhere, I just sort of came up with them. And so one of the first ones is usability, that you shouldn't have to know about the giant word cloud which I showed you earlier in order to start using Python packaging, and that the needs of the simplest use cases should be simple to do. People always want to do sophisticated things with Python packaging, and probably they should be able to, but they should never break the simplest use cases, like as I showed you, installing Django and starting to use it. Another thing is that everything should have a specification rather than just being defined by the implementation. So in theory, all of Python packaging will be independent of pip and the specific implementation of PyPI, and you, in theory, be able to create a parallel infrastructure and re-implement all this stuff just by reading the correct paths. Another important thing is, which hasn't, a lot of people who are using Python packaging don't see this quite yet, but in the future it will be more important, and that is declarative configuration. And so that means your metadata will be in a JSON file or some other static file rather than setup.py. And so this makes it a lot easier for various tools to parse the metadata and also improve reliability. And another important, if general, thing is pragmatism. This is especially important in Python packaging, which has a 20-year history, which means that there's a lot of sort of old, crufty features which somebody is using, but in order to make forward progress, you may have to break them. You know, switching PyPI to HTTPS from HTTP broke a lot of people, but probably the security benefits far outweighed people having to fix their code for that. And then a final thing, I think this is the final thing, yes, okay, is all this is taking place outside the standard library. And that's important because the standard library takes a very long time to evolve. CPython is only released every 18 months, so anytime you want to add a new feature, then you have to wait a year before you can use it in a released version of Python. It's also important because Python 2 is definitely not going to be getting many packaging improvements, but still a lot of people need packaging to work with Python 2 because they're still using it. And so having packaging developed outside the standard library gives it a lot more flexibility. And one day, hopefully, Disutils will not have to be used in Python packaging. It will be completely superseded by these technologies that I've been talking about. And that brings my talk to a close. I wanted to say that there's this documentation at packaging.python.org, the Python Packaging User Guide. It doesn't have everything in it. It's not complete yet, but it does have a lot of information about Python packaging and current best practices, and explains some of the large list of words which I put up at the beginning of the talk. So thank you very much for listening.
О, много желающих. All right. Thank you, first of all, Benjamin, for working on such great projects like Six and PyTest and PyPy, of course. I have two questions. So the first one is about metadata version 2.0, as you said, about JSON files. I haven't seen any activity for a while about this PEP, if I remember correctly, 426.
Wow, that's very good. Yeah, so for context, metadata, there are several PEPs about metadata for Python packages, which is things like the name of the author and also like what the source files are. And these PEPs define what that metadata is. And sort of the newest provisional version is metadata 2.0. And one of the significant changes is that it's the canonical format is a JSON one. And so, yeah, discussion has been dead for a while on that, but these PEPs have a way of being written, and then there's a flurry of discussion, and then they come back in a few years. So I think I would have to talk to people more involved with that, but I would not be surprised if it sort of came back and was completely accepted soon.
Okay, thank you. And the second one is, don't you think that pip as a default packet manager, which is now included in Python, should take something from package managers of other languages like Gem or NPM? For example, instead of suggesting for novices to go to GitHub and search for lots of cookie cutters projects, don't you think that pip should have something like pip init command? Or instead of running Python setup.py, build Buddhist wheel and so on, we would have like pip build just command and so on.
So so instead of using setup.py for actually building packages, you would use pip.
Yeah, and instead of making files manually, so this manifest.im and setup.py and setup.cfg. So instead of all of this, we could just do pipping and that's all.
Yes, I think we are moving towards a world where that will be more possible. I don't know of any concrete discussions to that effect, but yes, I think we want people to stop creating setup.pys.
What if I want to deploy the Python itself along with my application and all libraries compiled with a single executable on what core is doing? Is there any plans to support this natively in Python itself?
So did you read Glyph's blog post about this?
No.
Okay, there was just last week, somebody published a blog post talking about how one of Python's major failures is that it's very difficult to create a self-contained executable, either for like a client-side application, like an actual windowed application, or for server codes, you just like push a binary which has Python interpreter itself and everything in it to a server, and there's no problems with dependencies. No, there's depending on what your use case is, there's things like py2app and py2exe which sometimes work, and it's certainly one of the major weaknesses of the Python packaging ecosystem that there's no good solution for this, especially compared to newer languages like Go, where you just get a Go binary and then you copy it anywhere and it will work. So I don't know of anybody working on sort of a canonical solution for this problem, but it's certainly recognized as a major issue.
Hello, thank you for your talk. And I have a strange question, or not question. Your talk and story of Python packaging looks like a story of some ugly solutions, and current solutions is so ugly than that was before them. Pip is ugly and just sometimes don't works, and it's always need to be updated. It's always old version and the latest Ubuntu distribution, and you need to update it. Wheels just need to be installed before you try to install something from Wheels. Wheels are just X, but not X, but Wheels, but we just reinvented that. And React is ugly. It's not solved this problem because in every real installation you have a lot of dependencies, not Python but system-wide, like headers, libraries, and you just can't solve the problems with these solutions. And in history, Python just changes one solution to another and forces me to change my architecture, redesign it, but in other languages, maybe just works for 40 years. And yes, in C++ there's problems, but just works. What should I do? What should I choose? And how I should design my build system and not redesign it in 5 years.
Yeah, so software is terrible. Yeah, I'm. This is why the talk is called progress, not like Python packaging solutions.
It's progress in 20 years, and no changes, no real changes. You just replace one ugly solution with another ugly solution. I just can't find any difference with X and Wheels. First, we say we need binary distributions. Yes, X, okay. Then we say, no, we did not need binary distributions. Okay, we throw away X and live without that, but it's painful. And then we, second time, say, we need binary distribution. And in 5 years, we just throw away it.
I doubt I can tell you anything which will make you happier.
Hi. When previous speaker was talking about JobLib, he mentioned that this library has no external dependencies, and it surely meant to be a good thing. For me, as a newcomer language, I, as a newcomer, have a strong impression that managing external dependencies for system-wide available tools like CLI utilities is still a great pain in Python, mostly to the flat structure of requirements file, maybe. So, the question is, what is the best way for now to manage such utilities that must be accessible system-wide, so you cannot use virtual env? And are there any plans to adopt nested dependency structure, such as in NPM or Composer, maybe? Thanks.
Okay, so you can run system utilities in a virtual env if you're willing to sort of not follow the Unix philosophy. For example, I was in a job where we basically had apt packages of virtual envs, and then the command line utilities were symlinked into /user/bin from the virtual envs, and that pretty much worked. It also that touches on the sort of self-contained Python program problem, in that we don't really have any good way of creating a binary or a single file which uses Python and a lot of dependencies. Nested dependencies. Part of the reason, if you try to install something with pip, it can resolve nested dependencies. But most of the time with requirements file, you list the entire set of dependencies. And part of the reason for that is that upgrading a dependency of dependency can break you. So it's often best practice to fix the versions of every transitive dependency that you're using. Does that help? Maybe?
My remark is do not do recursive dependencies. What about, I want to ask about plans for PyBA organization. Okay. Are there any plans to cover modules or to cover some orchestration tools like virtual wrapper to specify and stabilize some API for such orchestration?
So the way that most things become maintained by PyPA is that the original maintainer goes away and that it's unmaintained, but somebody still needs it. So PyPA takes over. I don't know of any concrete plans to add orchestration APIs. All right. Well, thank you again.
One more question.
Okay.
One more question. Are there any plans to unify the packaging naming? Because, well, there are several problems nowadays. As you know, Django has a capitalized package name. Several packages have dash, several underscore. There is no general version conversion, and several packages like Flask need to create, to invent some tools to make extensions. Are there any plans to deal with it?
So, not naming specifically, but there in Python 3.3 there's something called MeanSpace Packages, which you can have a Python package can be implemented by multiple directories rather than just a single directory, and so you can have like a Flask extensions directory, and then or a package, namespace package, and then there can be multiple directories which are all part of the Flask extensions package. And then there's also setup tools entry points, which are sort of a generic kind of plugin system for for accessing a package can like say, oh, I'm going to look for an entry point for a Flask extension, and then Flask extensions, when you install them, can say, I know how to be part of this entry point. I think that addresses part of the sort of the plugin model, like how you install plugins, right? I don't know if we're going to try to invent a new naming convention for Python packages, because that touches on something much more fundamental and difficult to change.
Thank you.